Okay, welcome back. Now we're going to work on the actual factoring part of factoring trinomials. And let's take some of the examples that we did for the multiplication part and see how we can undo the multiplication, because that's what the factoring really is. So if I wanted to factor x squared plus 5x plus 6, I know if it factors, I'm going to be able to factor it into two binomials that look like that. X squared, that's pretty easy, comes from x times x. In order to get 6, I have to use a 3 and a 2, or I could use a 6 and a 1. But I know that because the last number is positive, that the signs here are going to be the same. That means I need the sum of whatever I put here and here to equal 5. So I'm going to be using the 3 and the 2, not the 6 and the 1. So 3 and 2. And everybody's positive, so these are going to be plus signs. If I had x squared minus 5x plus 6, the reasoning is going to be the same. I'm still going to have x and x. I'm still going to have a 3 and a 2. But this time, because the coefficient of x in my trinomial is negative, these are both going to be negative, so that I get positive 6 for the constant term. I have to write a little smaller. Okay. If I have x squared minus x minus 6, now with the constant term being negative, the ways I can get 6 are still 3 times 2 or 6 times 1. But because this is negative, I know that the signs have to be the opposites of each other. That means I need the difference of these numbers to give me the absolute value of the coefficient of x. So I need the difference to equal 1. For 3 and 2, the difference is 1. So I know that I'm going to be using the 3 and the 2, not the 6 and the 1. And the last thing I'm going to do is put in the signs. Which of these products has the larger absolute value? Let's see. 3x compared to 2x. 3x is larger, so I want to make this negative and this one positive so that it turns out to be negative. If I have x squared plus x minus 6, all of the work is the same up until the point where I put in the signs. But this time I want this larger coefficient here, this product, 3x, which is larger than the 2x. I want that one to be positive to match this sign, so this time this gets a plus and this gets a minus. So those are the easy cases where the lead coefficient for the trinomial is 1. What happens when the lead coefficient is something different from 1? Let's take a look at 6x squared plus 11x plus 4. Well, now there are a lot more possibilities, aren't there? So trial and error could be lengthy, but we can be systematic about it. And so the way I have urged students for decades to do this, and they're generally grateful, so I hope you will be too, is to make a list of the ways I can get 6. I can get 6. I'm going to make this so that the answer isn't going to just pop out immediately. I can get 6 by either taking 6 times 1 or 3 times 2. Now I'm going to look at the ways that I can get 4 because when I put my numbers in, the ways that I make 6 are going to go in the front here, and the ways I make 4 are going to go at the ends there. So to get 4, I can either do 2 times 2 or 4 times 1. Those are the only ways. And so if I were to do trial and error, the worst case scenario is I have to go through this whole chart, and I'll show you how to do that in a moment, in order to find the right combination. Okay, so when we do the multiplying, I multiply one of the first guys by one of the end guys. So I'm going to try these products. I call these the little products. And if this thing is positive at the end, I want the sum positive, sum. I want the sum to be 11. So 6 times 2 is 12. 1 times 2 is 2. That sum is not 11. 6 times 2, nope, not 11. 24 and 1, not 11. 6 and 4, not 11. 6 and 4, not 11. 6 and 4, not 11. 12 times 12 plus 2 is not 11. 3 and 8. Aha, that's 11. So this was the solution. That means that I have to put my numbers into the parentheses so that 3x has to get multiplied by 1. So where does the 1 go? So it gets multiplied by the 3. Not here. The 1 has to go here. That means that the 4 goes here. So now I have 8 and 3. This was plus. The signs are going to be the same, and they're both going to be plus signs because I have plus 11x there. If I had a minus here, it would be just the same thing, but at the end I would have minus signs. So now let's take a look at one of the other cases. Let's look at 6x squared minus 5x minus 4. So this is one where the constant term is negative. That means that the signs inside my parentheses here are going to be different from each other. Okay, so to get 6 times 1, or 3 times 2. To get 4, this time I'm going to write 4 times 1 or 2 times 2. 4 times 1 or 2 times 2. Okay. Because this is negative, a minus sign, I want the difference now to equal 5. So 24 and 1, difference is not 5. 6 and 4, difference is not 5. 12 and 2, difference is not 5, and that's also 12 and 2, so that didn't work. 12 and 2, the difference is not 5. 3 and 8, aha, there we go, the difference is 5. So 3 and 8. So I'm going to fill in 3x and 2x, and I need the 3 to be multiplied by the 1. That means the 1 has to go here, and that means that the 4 goes here. Now, I want to wind up with a negative 5 here, so out of 4x and 3x, which of those needs to be negative? Well, the 4x needs to be negative so that we wind up with a negative 5 there, so that's a minus sign, that's a plus sign, and we're done. That's the method. Good luck with it.